Hi friends, we're still in chapter 3. We're working on operations with rational numbers, and today we'll be discussing section 3-4, dividing rational numbers. Our vocabulary today is the multiplicative inverse or reciprocal, and it's when the denominator and numerators, I think the word are interchanged, might be better in a fraction here, sorry about that. So what you'll see is that 3/4 has a reciprocal, and of course the word reciprocal, as we're realizing here, could be also called the multiplicative inverse, and then we get 4/3. The reason why it's called the multiplicative inverse is because when I multiply 3/4 by 4/3, I get 1. These guys cross cancel and I have that. So that's our only vocabulary word or terms for today. And let's get straight to the examples. What you're going to notice in this lesson is that you guys are going to have your own problems to try on your own. And this is really important, and it should be a part of your notes. So make sure after I go through my example, you take the time to take a look at your example. So my example is over here on the left. We're going to find the multiplicative inverse of each number. That's pretty simple. Multiplicative inverse is the reciprocal. So in this case, it's 16/7. Notice I interchanged the denominator and numerators. Over here, this one is a mixed number. So we need to change that mixed number into an improper fraction. And of course, we do that by multiplying that -6 times 3, and then we're going to add the 1. So -6 times 3 is -18. Very interesting. I almost told you something not right. Let's hold the negative out for a second. And we know that this is a negative fraction. We're going to treat this like this. So 6 times 3 is 18 plus 1 is 19. And then at the end, we just have a 19/3 over a +3. And we leave it like that, or -19/3. The reason why I paused myself is because I was going to tell you to do -6 times 3 gives you -18. Then I was going to say -18 plus 1, which we know that's actually going to be a -17. So don't do that. Hold the negative at bay, in a sense. Change that mixed number into an improper fraction, and then bring the negative right back in there. And you have an example like that here and here. Make sure you try it. Again, the try it answers are going to be at the end of the video lesson. You can pause me if you need to. So here in example 2, we're actually going to get into division. And the division, when we're dealing with dividing fractions, I'm going to put some information here, dividing rational numbers. If we have A over B and we're dividing it by C over D, what we end up doing is we take A over B and we multiply it by the multiplicative inverse of C over D, which is D over C. And then we just multiply as usual. A times D is AD, and then B times C is BC. So the answer to this problem down here will be the same as the answer to the division problem here. So for part A, let's get back to the problem over here. 1/9 times 12/5. We've taken the reciprocal of the number after the division sign, and we're going to proceed like we would with multiplication. I could multiply 1 times 12 and 9 times 5, which is cool, but I want the answer in simplest form, and so that requires me to reduce at the end. An easier way to do that is to simplify. If we can cross cancel, we do that. I'm crossing out 9 and 12 because 3 goes evenly into both of those. 3 goes into 3 goes into 9 3 times, and 3 goes into 12 4 times. Now, when I multiply 1 times 4, I'm going to put the answer on this side, I get 4/15, and because I successfully cross-canceled, it's already reduced. I'm in my simplest form. Let's take a look at part B. 3/7 times, what's the multiplicative inverse of 8? I hope you said 1/8, because if you did, you're correct. And at this point, we're going to multiply across. I'm looking and I'm trying to see if there's some cross-canceling possible, but it doesn't seem to be. There are no like terms in the values that are diagonal from one another. So I end up with 3/56. And I believe that's the best we can do. Please try it problems now. So example 3 brings us to the concept of dividing by mixed numbers. And so what we'll do with our mixed numbers, and I know you've practiced this earlier, is we're going to take our mixed numbers and turn them into improper fractions. So remember what we did last time? We're going to hold that negative at bay, and I'm going to say 3 times 4, which is 12. I'll add 2, and I'll get 14. So this is a negative 14 over 3, and I'm dividing it by 3 times 9 is 27, plus 1 is 28, 28 ninths. And remember what we said. When we divide fractions, we actually end up multiplying by the reciprocal. So negative 14 over 3, this stays the same, times 9 over 28, the reciprocal or multiplicative inverse of 28 ninths. So I'm simply going to do what I know how to do, which is to cross cancel. 3 goes into itself 1 time, 3 goes into 9 3 times. 14 and 28 have a common factor, which is 7 and 14. So when I divide 14 or negative 14 by 14, I get negative 1. And when I divide 28 by 14, I get 2. This problem's a lot simpler. I now have negative 3 over 2, which is totally awesome and correct. So the answer to this problem is this. Please try this problem. These types of problems are often found on standardized tests, so take a look at example 4. Tessa feeds her dog Roscoe 3 3/4 cups of dog food per day. If she buys a bag of food that contains 165 cups, how many days will the bag of dog food last? We have some answer choices here, and I like standardized tests because the answer is often on the page, and so that gives us a unique way of finding the solution. Oftentimes we could look at the numbers, like I'm looking at 165 and 3 3/4. I can say that 165 divided by 3 3/4, which is about 4, right? I can look at that and try to divide 165 by about 4, and the answer that comes closest to this will be the answer that I choose. However, since we are not just practicing for a standardized test, I want you also to have the concept down. So ultimately, we're taking 165 cups, that's the entire bag, and we're going to divide it by the amount that Tessa feeds her dog on a daily basis. So we end up with 165 divided by 3 3/4. What we'll do is we'll take our 165 and we'll multiply it, 165 over 1, make it a fraction, make it a rational number, and we'll multiply it by the reciprocal of this. But to find the reciprocal, we first need to change it into a mixed number. 3 times 4 is 12, plus 3 more is 15. So I end up with 15/4. But we need the reciprocal, so 4 out of 15 is what we're going to use. Clearly, I see that 15 and 165 have a common factor, and I know that 5 goes into both of them, but I suspect 15 does too. 15 goes into itself 1 time. 15 goes into 165 11 times. That's going to make my life much more simpler. So now at this point, I'm going to multiply 11 times 4. I get 44. In the denominator, 1 times 1, I get 1. So ultimately, this is 44 days that, that Tessa will be able to feed her dog, given the bag of dog food that she has purchased. Why don't you give this one a try? A box of cereal contains 15 3/10 ounces. If one bowl of cereal holds 2 2/5 ounces of cereal, how many bowls of cereal are in one box? So I think you guys can try that on your own. So here's our last example, example 5. We're going to discuss dividing algebraic fractions. The process is the same, concept slightly different because we're dealing with these variables. But the idea is the same and the principles are the same, so it's not going to be too bad. Let's try this problem first. So I've got 5 over 3ab divided by 15 over abc. Just like I would with any pair of rational numbers that I'm dividing, I take the first one, I leave it exactly as it is, and I change the operation to multiplication, and I take the reciprocal of the term or the number after the division sign. And I see beautiful things here, right? Because I can cross cancel. 5 goes into itself 1 time, 5 goes into 15 3 times. And then look here. 3ab and abc have common factors as well, a and b. So I can actually cross cancel those out. So now in the numerator of my answer, I've got 1 times c, which is c, and in the denominator, I've got 3 times 3, which is 9. So when I simplified this or found the quotient, remember quotient, this word here is the answer you get when you're dividing. When I simplify this, I get C over A. Pretty cool. Here's the last problem I'm going to ask you to try. Pause it, and the next slide you'll see will be the answers. So friends, here are the answers to the try it problems. I think it's really important that you do give it a good go and try these problems, and this will really inform whether or not you have questions about the lesson before you start your assignment. Please see your assignment right here or in your packet, pages 144 to 146 and the following problems. Have an excellent day, guys.